Hello, hello, and welcome back to a wonderful day of pre-calculus. Today we're going to be talking about solving equations, specifically quadratic equations. Let's get going. As a reminder, just real quick, actually, before we get over there, as a reminder, quadratic equations are the ones that have the squares in them. So that's a quadratic equation. That's not. That's got a cubed. Square y cubed plus y. That's a quadratic equation. And anything with a squared. Like all of the squared things are quadratic equations, and there's also things that are like quadratic-esque, but we'll get there. Whoop, come back. All right, so factoring. In order to solve quadratic equations using factoring, we always get all of the terms to one side of the equation. Then we factor the quadratic equation using those cool factor forms that we talked about in lesson 2, I think. So, last week or a couple weeks ago or whatever it was, told you factoring is not going away. We're going to do it again. And then we're going to set each of those factors individually to 0 and then solve each of those like little mini linear equations for x or the variable or whatever it happens to be. And then if we have multiple answers, remember to list them inside the curly brackets. We'll talk about what the curly brackets specifically represent when we start talking about inequalities. That's coming up in a few days. So let's get going. We've got an example 2x squared plus 6x equals 80. I want all of the things on the same side of the equation. So I'm actually going to subtract 80 and move it to the same side. It's kind of counterintuitive to do this because a lot of times when we're solving equations, we're trying to get the variable by itself, and shoving everything all together feels counterintuitive and kind of backwards, but it works. Remember when we're factoring, the first thing we always look for is a GCF. So we're going to pull out a 2, x squared plus 3x minus 40. And because this is all equal to 0, I can just divide both sides by 2, and that just bloop, goes away. And I can ignore it. X squared plus 3x minus 40 equals 0 because it's an equation. If this was not an equation and just an expression, you would have to keep the 2 there. Okay, we've gotten all the terms to one side. We're not going to factor. We've pulled out the 2. Now I need to figure out what multiplies to negative 40, but adds to positive 3. 20 and 2, no. 15 and 8? 15 and 8. No, that's too far apart. It is divisible by, not 15 and 8, 5 and 8. 5 and 8, positive 8, negative 5, there we go. X plus 8, x minus 5 equals 0. And then the next thing I need to do is set each factor equal to 0. X plus 8 equals 0. X minus 5 equals 0, x equals negative 8, x equals positive 5, and there's my 2 answers. I'm going to put them inside of curly brackets. All right, okay, that wasn't bad. We're going to do this guy over here too, just for kicks and giggles. 10w is equal to 0. I can factor a GCF of 2w off of these guys. So this makes it 2w plus 5 is equal to 0. So 2w equals 0. 2w plus 5 equals 0. And w equals 0. 2w equals negative 5. W equals negative 5 over 2. So in my curly brackets, it's negative 5 over 2, comma 0. Bada bing, bada boom. We're done with factoring. Moving on. The square root method. This only works if you have an x squared and no x term. So something like this, beautiful. 27x squared, also beautiful. And we can even like add a constant onto these guys. That's perfectly fine. We're good. We're beautiful. Everything is golden. As soon as you turn into 27x squared plus 7 plus 12, no. Cannot do that. No! We can't have that linear, 7x. We can't have that linear part of the thing. So what we're going to do is we're going to get the x squared by itself, and then we're going to square root both sides of the equation. And the side without the x gets a plus minus in front of its square root. So let's do it. We're going to get the x squared, or the d squared in this case, by itself. So 16d squared equals 81. D squared equals 81 over 16. And then we're going to square root both sides, or mainly actually the other side because we're getting rid of the squared. And that gives me d equals plus or minus 9 over 4. And that's technically two answers. So floop, plus minus 9 over 4. You could also write that if you like the plus minus thing just really bugs you. You can also do it this way. Either way. And then we go over here. That was nice, right? That wasn't too bad. 10, move over there. Negative 7s squared equals negative 9. S squared equals negative 9 over negative 7. So s squared equals, I just like cleaning up my fractions. There we go. And then s is equal to, trying to make this look more s-y and less 5e, plus or minus the square root of 9 over 7. So s equals plus or minus 3 over square root of 7. Ah, man. I can't leave the square root in the denominator. That breaks the rules. I'm not allowed to do that. So we're going to multiply the top and the bottom by square root 7. Woohoo! Equals plus or minus 3 root 7 over 7. Now I'm done. Curly brackets, and we're good. That's the square root method. This one is the one that we actually need to spend some quality time on, which is why we went through those other two very quickly. Completing the square is complicated. We're going to go with complicated. Completing the square is complicated. There's a process. It is a 6-step process. This is the longest thing that we've talked about so far in this class. A lot of times people that are really good at math, like they can just look at one of the linear things and go, oh, well, clearly that's x is 5. Completing the square is the first time where people are like, what now? And so this one, if you're one of those people that math is always just, oh yeah, really easily to, you need to trust the process on this one. If you're somebody that you've struggled a lot with math, you're used to trusting the process and you know how to do that. You just follow the directions one step at a time. Even if you're kind of lost a little bit, you just keep following through and you eventually get to the other side and things are amazing. So if you're one of those guys that's like, I can just look at it and I don't need to go through this process, you do have to go through this process. We're about to go and meet things called, what are they called? The brain ran away. Where did it come back? Conic sections. They're called conic sections. And you have to use completing the square in conic sections. You can't use other methods for simplifying down quadratics. You have to use this process. You're going to have to use this process in this class. Figure it out. Get it into long-term memory. Get it on a note card. Practice these quite a bit. They're annoying, yes, but they're the only tool that we have that works on conic sections. So we have to understand how they work. So we're going to rewrite it as ax squared plus bx equals c. In other words, get the constant on the other side, keep all the x's on this side. We're going to divide both sides by a, that leading coefficient, so that it looks like x squared plus bx equals c. Note, b and c in step 2 are not the same b and c as they came from step 1. We've divided them by a. It's not the same number anymore, but we still want to kind of say b and c because that's kind of like our placeholders for the thing in front of the x and the thing that doesn't have an x next to it. And then off to the side, we're going to take b, we're going to divide by 2, then we're going to square it. So take b, divide by 2, then square. And we're going to add this number to both sides of the equation. We've now officially completed the square. We have created a perfect square trinomial on one side of the equation. So we're going to factor that perfect square trinomial. You're either going to end up with a plus b or a minus b. These a's and b's are different than the ones up above. Sorry. And then we're going to take the square root of both sides. And don't forget that the side that doesn't have the x is going to end up with a plus or minus in front of it. And that's going to create two different cases. Blah, blah, blah equals positive square root. Blah, blah, blah equals negative square root. And then you solve both cases, simplifying all irrational or complex answers. Blah, 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 blah. That was a mess. All right, we're going to zoom out just a little bit so I can see those steps. Rewrite as ax squared plus bx equals c. Okay, so that's my first step. We're going to add 25. So I might just zoom in a little bit so I can see better. So that's 7b squared plus 14b equals 21. Okay, that was my first thing. Now I'm going to divide both sides by a. Okay. A in this case is 7. So I'm basically just dividing all of the terms by 7. This becomes b squared plus 2b equals 3. Okay. Now to the side, we're going to take b, which in this case is 2. We're going to divide by 2, and then we're going to square. It's going to become 1 squared, which is just 1. Remember this number right here. We kind of use him again. So now I'm going to add that to both sides of the equation. And now we're going to kind of clean things up a little bit. 3 plus 1 is 4. And then b squared plus 2b plus 1 is a factorable thing. So we've done all of this work to set this up so it's factorable. If you need to go through and do the thing, okay, what multiplies to 1 and adds up to 2, that's totally fine. These two numbers off to the side will always be the same in this particular setup because we created a perfect square trinomial. So this is going to become b plus 1 squared. Oh. And we keep the sign that's right there. So b plus 1 squared, and we got the 4 on the other side. So now we do the square root thing, plus or minus the square root of 4. And we're going to split this into our 2 cases. Oops. I was supposed to do the square rooty thing in a different color. Oopsies. All right. Not that it matters, but I started color coding, so let's keep color coding. So this is b plus 1 equals 2, and b plus 1 equals negative 2. And now we're just going to solve things, right? Yeah, just solve things. b equals negative 1, b equals negative 3, and there's no complex or any other nonsense going on. And we can move on with life. Okay, that one was like, a nice little warm up, warm and fuzzies. We're going to play with one that's a little bit more interesting now. I know. Interesting is not really what math students want to hear. The teacher goes, oh, here's an interesting problem. I remember when I was a student, I'd be like, oh no, how are you going to torture my poor little brain now? So here's an interesting problem. I've got that down. Next thing we do is we divide by that a. So we have a squared minus 5a equals negative 49 over 4. Well, that's delightful. That's a fraction. And there's nothing I can do about it. It's just going to hang out for the ride. All right, off to the side, we're going to take b, which in this case is negative 5. We're going to divide by 2, and then we're going to square it. So that becomes 25 over 4. And we're going to add that to both sides of the equation. A squared minus 5a plus 25 over 4 equals negative 49 over 4 plus 25 over 4. All right, we're going to clean up the right-hand side first. Negative 49 plus 25, 9 minus 5 is 4. 4 minus 2 is that. Oh, hey, that's cool. That simplifies to negative 6. Whew, that actually makes that side a little bit nicer, so yay. This guy, that's a fraction. Most people find factoring with fractions kind of irritating, which is why we're going to go back to looking at our b. And this step right here, where we divided by 2, that ends up being the term, well, in this case it's a minus 5 over 2 squared is what this perfect square trinomial turns into, which is part of the reason why we pay attention to this, because I personally do not want to think of two things that multiply to 25 over 4, but then add up to 5, negative 5. Turns out it's negative 5 halves. That's cool. All right, now our next step is to square root both sides. Chaboop, chabop. And we have a minus 5 over 2 is equal to plus or minus square root negative 6. Ew. We can't leave the negative inside of there, so it's I root 6. Okay, and then we split this into 2 cases. A minus 5 over 2 equals positive I root 6, and a minus 5 over 2 equals negative I root 6. And then we finish by solving each piece, and basically just moving the 5 halves to the other side. I root 6. And a equals 5 halves minus I root 6. So we have 5 over 2 minus I root 6 and 5 over 2 plus I root 6. You can also write this as 5 over 2 plus or minus I root 6. Perfectly valid to do that as well. Either one, don't care. And there we go. So we've done completing the square. That was the scariest, hairiest one of them all. If this did not make sense, or you're still a little shaky on this, I highly recommend pausing the video right here and doing a couple more of example problems with this process. No shame in that. You need to have this down. We are going to use this again in this class when we deal with conic sections. This is not going away immediately. So, All right, the shortcut, because pretty much everybody hates the dealing with that wonderful completing the square method. So if you take the ax squared plus bx plus c equals 0, and you go through the process of completing the square with a, b, and c as stand-ins for the numbers, you end up with this beautiful equation called the quadratic formula. It's actually a formula, not an equation. And you can go through that whole entire process. I'm not going to take the time because this lecture time is precious. So you basically just get this really cool formula. So you can go through the entire completing the square process, or you can use the shortcut, the quadratic formula. When we're dealing with conic sections, we can't use the shortcut, which is why we need to know how to complete the square. All right, let's do our process. Okay, we need everything on one side of the equation, blah, 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 equals 0. So that's going to give us negative k squared. No, I don't want a whole bunch of negatives. We're just going to move everything over there. 0 equals k squared plus 10k plus 8. But Miss Norton, it says you're supposed to write it as ax squared plus bx plus c equals 0. Okay, fine. Flip the equation. K squared plus 10k plus 8 equals 0. Same thing. You can mirror flippy, it's still okay. All right, and now we're going to plug our things into the quadratic formula. At this stage, I personally, off to the side, like to write a equals 1, b equals 10, and c equals 8. I am not as detail-oriented as I once was, and sometimes I lose track of what letter was what. So I like having that off to the side, because then it helps me remember where I'm plugging things in. Negative b plus or minus the square root of b squared minus 4ac over 2a. All right, this thing right here, this needs to go into your long-term memory. If you have not stored the quadratic formula somewhere where you can, I can remember what, pull that out, you need to. It's going to keep coming back to haunt you throughout this course, throughout calculus. This thing doesn't go away. So please put that somewhere where you can remember it on a test, all that fun stuff. All right, let's plug in our numbers. So x is equal to negative 10 plus or minus the square root 10 squared minus 4. Technically, we should be putting these things inside parentheses. 4 times 1 times 8 all over 2 times 1. So x is equal to negative 10 plus or minus the square root of 100 minus 32 over 2. X equals negative 10 plus or minus, 100 minus 32 would be 68 over 2. Oh, gosh darn it. 68 is not a perfect square. So 68 to 34 to 17. I've got a pair of 2's. So this equals negative 10 plus or minus 2 square root 17 over 2. And we're going to put this into like its real and component form because I want to be able to simplify this thing down. 2 root 7, it's all real. What am I talking about? There's no negative inside that square root. All right, fine. The radical and the non-radical, whatever. Shoop, schwap. Technically 2 solutions. Fine. X equals negative 5 plus or minus the square root of 17. And that's that. Beginning to think that dark blue doesn't quite work out. All right. Completing the square will be used when dealing with conic sections. Wrote myself a note to remind you about that. It's coming. Don't just skip over those. You have to know how to do this. Linear and quadratic equations will return later when we start talking about the polynomials unit. Yay! And of course, when we're talking about the conic sections. Our next video is going to be over, again, solving equations, but this time we're going to be talking specifically about radical equations. I call this level 4A because I don't necessarily think that radical or rational equations is necessarily one is easier or harder, so it doesn't really feel right to call one of them level 4 and one of them level 5 when they're about the same level of difficulty. So level 4A is radical equations. Come back tomorrow for that. Don't forget to look through your notes, make sure that stuff makes sense, especially completing the square. And as always, don't forget to fill out that video reflection form. Happy mathing!